In example 8, and we are supposed to find the range of each of the following functions. The range of each of the following functions. And the part A, the function of x is given by 3x minus 2, and the domain of x, the domain means the input. The value of x is equals to 1, 2, 3, 1, 2, 3, and 4. Those are the possible values of x. And in this one, we are supposed to work out the function of x, substituting each and every value of x within, and therefore y, which is now the function of x, is equals to 3 multiplied by 1 minus 2. This is 3 minus 2, 1. We can call that y1. You can call this one y2 when fx2. This is when we have 3 times 2 minus 2, which is equal to 6 minus 2 is 4. Moving like that until we have, when x is equals to 3, then we have 9 minus 2, 7. When x is equals to 4, then we have 12 minus 2, and we have a 10. So we could have a diagram that looks like this. We have x1, 2, 3, 4, and that is x, and we have y now that talks of 1, 4, 7, and 10. 1 maps to 1, 2 maps to 4, 3 maps to 7, and 4 maps to. So what can we say about the range? In this case now, the range, which is now the value of y, the range of fx is from 1, is 1, 4, 7, and 10. That is the range, or rather the possible values of y. Already you can see this is a 1-to-1 mapping. It's a 1-to-1 mapping. Let's look at part B. Part B talks of gx, the function of x, which is x squared, and the domain, x is a real number, and x is between, x is greater than or equals to minus 5, less than or equals to positive 5. And this one, it goes without saying, because x is going to be squared, it's simply talking about a quadratic function. When x is minus 5, and when x all the way to boundary, then you can see this is many to one mapping. In both cases, y is a 25, because you can see in both cases, when x is greater than minus 5, let's say minus 4, you can see y is a 16. When it is a minus 3, y is a 9. When it's a 0, y is 0. And all this can be reflected on both sides. So the range of fx is greater than or equals to 0. And of course, when it is greater than or equals to 0, it is less than the same range is less than 15. So the same this is gx, the same range of gx is less than or equals to 25. So when you combine the two, you will get that the range of the function of x greater than or equals to 0, less than or equals to 25, because all these values between 0 to 25 make sense, because the domain itself is between the two limits, as you can see. But part C, let's look at part C here. Let's look at part C here. Part C is asking us the function of x, equals to 1 over x, and x is a real number and x is greater than 0, less than or equals to 3. So when we are having 1 over x, or of course this one is asymptotic, and we are going to have x is greater than 0, so it is not equals to 0. Please note, x is not equals to 0, so it's slightly greater than 0, and of course it's supposed to be a very small number of small value of x, and when you have 1, y is supposed to be 1 over a very small number, then we are talking about 1 divided by a very small number is supposed to be a very big number. So when as x approaches 0, y approaches infinity. So in this case, we are likely to have a function that looks like that. But of course, we cannot have it this way because we have an upper limit of a 3. When x is a 3, what is going to happen? Y is supposed to be 1 over 3, which is simply that, 1 over 3. So when x is a 3, y is supposed to simply be that, and this is a third. That is a third, the value of y. So at that point, y is equals to the function of x, or rather hx. What is the range? If you look at this graph, and with this consideration, as x approaches 0, y approaches infinity, such a big number. But on the contrary, it has a limit. It does not go below a third, simply because our x does not go beyond a 4. If you are supposed to show when x is a 4, when x is a 5, then our graph would have been produced like that. But now, because we do not have that provision, our final value of x is a 3, so you can already see the value of x, the value of y, start from there moving forward. So the range of the function of x is greater than or equals to a third. We do not have the upper limit of the function, simply because, as you can see, as x approaches 0, y approaches infinity. We don't know how close is x to 0, and therefore we cannot tell the extent of the infinity, and that is just like it. Finally, you can see every value of x maps to just one value of y, so again it is a 1 to 1 mapping, 1 to 1 mapping with that kind of range. All right.